Alright, good morning. Not all screens are working. Alright, yesterday we just started 3.2. We were looking at the properties of polynomial functions. And a polynomial was just a bunch of addition of powers of x's. Come on. Basically, for x to the 5, a number x and a raised to power, another number x raised to another power, and a number x another power. The properties of functions require that, polynomials require that those powers to be whole numbers and positive. Okay, we're not allowed to have a fraction or negative on the power. And the numbers in front of x should not be any complex numbers, no I notation. It should be only pure numbers, but they can be decimals, they can be fractions. And we'll take a look at some basic polynomials and their graphs. If the power is even, the polynomial graph is U-shaped. If the power is odd, it's kind of elongated S, okay, or inverted S looking type, okay. So this part kind of goes down, it's flipped downward. Except the first power is a line, it's a linear function. Alright, and we were taking a look at what happens to these graphs, polynomial graphs, on the far ends. I mean, when you go really far right and far left, where do they move? And we have observed that there are 4 cases can happen. Both ends can go up or down, or one up, one down. Okay? And unfortunately, we don't always graph these every time we speak up or down. We represent them with symbols. Okay, this means x going to positive infinity means x is getting large and large values, millions and billions. That means far right side. On the far right side, this is what I mean. We represent it by this notation. So when you see x arrow going to infinity, that means you need to imagine yourself on the far right end. And when we see this notation, x arrow negative infinity, negative huge values, you need to imagine yourself on the far left. So this means left side. Okay? And polynomials may vary in the middle. It's like a roller coaster. They may go up and down. So they are not predicted in the middle, but we can only predict them on the ends. Okay? And by the way, to say left arm going to infinity or right arm going to infinity, this is the symbol we use. F of x rising to huge values, going towards huge values. And if you want to say arm going to down, one branch going to down, this is the symbol we use. Arrow and minus infinity. F is going for negative huge values or positive huge values. Alright, let's take a look at our first question. Oh, I didn't tell you. So who decides which term? There are tons of terms here, right? Who decides how this graph is gonna act on the right or left side? It's called the leading term. It's the very first term with the highest power. We call it also the degree. That highest power is called degree. So that term containing the highest power is called leading term, kind of leader of the group. that term decides what kind of shape happens on the ends, depending on the evenness or oddness of the degree or power. If the power is even, it may either go both ends up or down. Both sides act the same direction, go the same direction, either up or down. How do I know it's up, not down? You need to look at the number in front. If the number in front is positive, it goes up. If the number in front is negative, it goes down. So all you need to do is, and when it's the odd case, you have left side going down, right side going up if the number in front is positive, left up, right down if the number in front is negative. Okay, so this is how we start. When I see the statement, describe the end behavior, all I need is take a colored pen, mark the leading term, and cross out the rest. You don't need the rest. Just take a look at the first term, leading term in the sequence. Negative 3x to the 4th. And then, second, I decide whether this power is even or odd. That's the second step. Step 1, mark the leading term. Step 2, decide whether the number on the exponent is even or odd. So what kind of number is this? It's an even number. So which case are we going to choose? We are going with even case, so I cross out this option because the power on the exponent is even. Now between even there are two cases. You may go both ends up or down, and to decide this you need to check the number in front whether it's negative or positive. Now this is the step 3. What kind of number is this? It's negative. So we are going to cross out this option. So you have the cases, left end going down, right end going down. That means f of x is going to negative infinity on both ends. So as this is the left side, when you go to left, f of x going to negative infinity. When you go to right, this means right side, f of x going to negative infinity as well. Okay? Alright? Look, could you have solved this question without help of this table? I could. Look, you don't need to memorize this table. It's really useful. You can put it on your note card. But this is what I see here. I mean, just use your reasoning. Again, I cross out everybody else except the first term. And look at the graph of x to the 4th. Don't you know the graph of x to the 4th? Come on. I am giving it to you right here, right? X to the 4th is U-shaped. Just sketch it. Sketch x to the 4th. Here is x to the 4th. But is this really x to the 4th? We have a negative sign. I need the negative of it. What happens if you put a minus in front of the entire function? It's one of the transformations. Yep, it flips over the x-axis. We reflect it along x-axis. So this is the negative x to the 4th. Well, do I care this is negative 3? No, 3 is just going to make it steep. Much more steep. And I don't care about 3. I just care about negative or positive. Now I'm going to clean the end parts, middle part. What do you see on the ends? That means negative infinity, negative infinity. Your function is going to negative infinity on both ends. Without using any table, you can do the same thing, okay? If you know the shape of basic polynomials raised to powers and what happens if you have a negative number or positive number in front, okay? All right. our next problem requires a little bit more work. Again, I put down the table here in case you need it. But what we need to do is first mark the leading term, right? And I say this is the leading term. Am I right? Always when I give you a question, compare it to the previous one. What is different here? Are they the same type questions? What's wrong with this one? Isn't this the leading term? The biggest power, I just marked it. Yeah, this thing multiplied by a couple of parentheses. That means there will be some x's when you FOIL everything, multiply out, distribute everything. There will be more x's combining into this x, and that power is going to rise bigger and bigger, right? So you need to compute that final leading term. This is not the leading term, false. If you answer your question with this, you're gonna end up with a false answer. Then how do I compute that leading term efficiently? Because I don't want to expand this cube. Look at this. It's triple product. And then I have to multiply this and that with that. Can you imagine how long this is? And I will get the first term like that. So we need to be efficient. So what do I need to do? Only take x's and raise them into these powers. And there is no power here, so you're gonna just take 3x, and this is single. So only multiply the stuff I mark. It's going to give you the term with the biggest exponent. Okay, so basically leading term will be product of negative 7x to the fourth times minus x cubed times 3x. Okay, let's clear something. What happens if you multiply minus x 3 times itself? It's negative x cubed. So I'm getting an extra negative here. There is another negative, 7 and 3. When I multiply all this, they become negative 7. Negative 1 times 3 is, what is it? Positive or negative? Positive 21, yes. And then I have fourth cube and first power. When I multiply them, 12 and 13, is that right? 4 times 3. Now we add them. When you're multiplying powers, you add these top. So it is 21x to the 8. Is it 10? How'd you get 10?
So 4 and 2 3s.
I don't get it. How did you get it? 2 3s? Look, this is 4, 3, and a single power, right?
You add the powers, not the...
We add the powers. 4 plus 3 is 7. 7 plus 1, 8, right? Okay, 21x to the 8 is the leading term. So this is going to shape the end behavior of this graph. And do you have an answer? What kind of shape is 8 power is? This is an even number. Even, positive. What is the case with even and positive? Both up. Infinity, infinity, that's it. You see, our initial guess is wrong. If you go with this, this says down. Down. Both down, right? You would get the wrong answer. Okay, let's proceed next. Any questions about the end behavior? This is going to be used when we are gonna graph polynomials today. We're gonna use this to find out the end parts of the graph. Alright, how do you figure out the middle parts then? This fact we are going to explore next is gonna help us figure out that in the middle how this graph is acting, how many times it's going up and down, where it's crossing x and y axis. Okay, now let's talk about zeros of the function. Zeros of the function are basically x-intercepts. The numbers you plug in f and it makes y into 0 is called x-intercepts or zeros of the function. Okay, but how do we get them? We always set y into 0 and solve for x. But before that, we need to factor it. So once you're given a polynomial, first thing you're gonna do is step 1. To find zeros or x-intercepts, you need to first factor it. Then we will set all y values into 0 or entire function into 0 and solve for x. Such as this thing, this example, this thing is already being factored. Factor, another factor, factor. 3 factors, okay? It's already been factored, so we are lucky here. They have done the step 1 for us. Then they set each in this thing into 0. In other words, they make this y into 0. Once a polynomial factored and set it into 0, all you need to do is take each piece and set it into 0. X equals 0, x minus 2 equals 0, x plus 4 equals 0 without the powers. You don't have to worry about the powers. Ignore them. Because that powers means this factor is 7 times next to each other. It's copied and multiplied 7 times itself. X plus 4, x plus 4, x plus 4, 7 times. Do I always need to take each of them and set it into 0? No, if you do it once, you will end up with the same answer all the time. And the results you get is called x-intercepts or zeros. But since some of these factors are repeated multiple times, we call it multiplicity, such as x equals 0 is the first answer, this one is 2, and the last one give us minus 4, and I have powers around them, 2, 3, and 4. They are called multiplicity, 2, 3, and 7, I'm sorry. Negative 4, 0, the negative 4 repeated 7 times because I have that factor 7 times itself, right? So it shows up 7 times in the expansion. That's what we call multiplicity. Okay, let's test on you. What if I add one more piece here, x plus 2, and put 5? So what are the zeros of this function now? I have 0 as a 0, 2 as a 0, and 7 as a 0. Now you have one more, which is negative 2. Always take the opposite of this number. Set it into 0, it will be opposite. Is a 0 of multiplicity what? 5, because I see it 5 times. Alright, we're ready for our next question. Alright, this question is not as easy as this one. Why? Somebody tell me why. Chris?
It's not factored.
It's not been factored yet. So we need to factor this. Oh my god. How do you factor such a thing? It's a mess. Anyone knows?
You pulled X out.
Perfect. We pull x out from where? From which terms?
From each of them that have X.
Okay. When you say that, that's not correct because not all x's have x. Not all terms have x. This guy has, everything goes okay until this moment. I can't pull an x out from this guy. Well, can I just take the x out from the first three? Yes, you can, but I don't think it's gonna help in the next step. Okay, here is a clue. When you see four terms in math and they say factor it, four terms, right? 1, 2, 3, 4. It's most of the time this trick. You need to factor, if there is nothing common between them, you tried x, that x wasn't common everywhere, right? Oh, do you see anything else common in every in each and every term? Anything else common? Then if there is nothing common between four friends, what would you do? They don't get along, right? They don't have nothing common. I pair them up, and two goes on their own way, and the other goes on their own way. They get along better, right? So I'm going to pair these two up and search for something common. First two, last two. Anything common you can pull from these guys. What is common? Greatest.
X squared.
Yeah, it's not just the x, but x squared. Perfect. I have two of the x's common. So when I borrow two x's from three x's, triple x, double x, when I borrow double of them, how many left?
X.
When I borrow two of these,
3.
good. What is common in the second group?
36.
Only 36. Okay. I'm going to borrow 36 and you will tell me what's going on. When I remove 36 here, what is left in this group? Negative x. When I remove 36 from 108, what is 108 over 36?
3.
Perfect. But it's negative, right? Because you said. Now, in the next step, we are going to search between these two groups, these two pair of groups, right? Two friends, anything common in there. X squared 36, not common. How about these parentheses? Are they common? Almost. Almost. I wish this was x plus 3 and x plus 3 both. It's not, because we were careless. We didn't pay attention to something. Instead of positive 36, why don't we take out negative 36 instead of positive? Let's see what's gonna change. Just pulling an extra negative. When I take this negative with 36 now, what is left in here? This is gonna turn into positive x. When I borrow negative 108 and I divide by negative 36, what is the result? That's plus 3. Right? Oh, look at this now. These two are match. It's a match. Is this magic? Is this just a coincidence? No. Whoever wrote this question arranged these terms so you can factor them this way, okay? So what do I do next? Since these are matching, I'm going to call them out here. So x plus 3. So you're kinda charging these two groups this amount of money. So these are taken away. I took these away. It's like tax. You're taxing each group the same quantity, and leftovers will be collected in this bag. So what is left over if you tax the first family, x plus 3? Who's left? In the second group, 36, but you have a minus in between. Okay? Is this factoring method make sense? Probably you have seen this before, but 4 terms, if they have cube and every other stuff, if you have 4 terms, first thing come to mind is 2 by 2 grouping and regrouping. Alright, next. Can I factor this more? Can I factor x plus 3? No, it's simple enough. If you are down to single power, you stop. Can I factor x squared minus 36? Can I? Anything more than 1 power, this is second power. In other words, quadratic is possibly can be factored most of the time. And this is one of them. Do you know how to do that though? How do you break this? It breaks into two more pieces. Anyone?
Take the square root of 4 times 6 x minus 6 x plus 6.
Good. We use square difference idea. If you have two terms raised into square with a minus in between, you can write them into two groups as A with a, and B, AB, once with a minus, once with a plus. But you may object, wait a minute, I have a square around x, but I don't have a square around 36. How can I use this one? I need a square in the second term, right? There is a square, right? Isn't that 36 6 squared? So this is x minus 6, x plus 6. You take kind of square root of each term, and then once you put minus, once you put plus. So x minus 6, x plus 6 is the answer here. So altogether, how many zeros do you see? So what was the question here? We are finding zeros, right? We factored it. All I'm gonna do is set these into 0 and solve. I set this x minus 6 into 0 and x equals 6. X plus 6 into 0 and I get x equals minus 6. I have how many zeros? 3 zeros, or x-intercepts, right? And what's the multiplicity of each? How many times each factor shows up? How many powers do you see here? All multiplicity 1. Alright? Multiplicity 1. Alright, let's check if we got everything right. We found 3 zeros. Check. They were minus 2. Was it minus 2? Minus 6, 6 and 2?
Minus 3.
Minus 3. Alright. And all multiplicity 1. Good. Alright, what is next? We now learn pretty much basics of polynomials. We have enough info about them. I bet we can sketch them now. Alright? So we compile what we learned so far about polynomials in 7 steps. And we're going to make our best sketch of them. It doesn't have to be perfect. These are again rough sketches. We roughly look at its shape, but you can make it better and better if you just take several more points and check their coordinates. But this is just for rough sketching purposes. Alright, how do we sketch polynomials? Let's follow these 7 steps. First, we need to describe its leading term. What is the leading term? Anyone can read the leading term? Come on.
X to the 5th.
X to the 5th. Second. Oh, we need to describe this behavior. So what kind of behavior is this gonna say about f? F of x is going to go where as on the right side? F of x is going to go where on the left side? As x is on the right, far right, and left, where does f go? If it's positive 1 x to the 5th, it's just 1, right? Tamam. Do you remember the graph of x to the fifth?
Just going down and it's going to go up.
Yep, left is going down, right is going up. Again, either use this table, it's odd and positive, so up, down, or down, up, or use this idea, x to the fifth is here, green picture, left side is down, right side is up. Either way is fine. We have our first result that's going to help us sketch this thing. So I'm going to put every time I get an information about the polynomial, I will put it here. So what do I have right now? The right side is going up, and the left side going down. Okay? What happens in the middle? I don't know. I don't know how many turns it makes, but eventually, and on the end, it's gonna act like this, okay? So let's find out what's happening in the middle. Step 2. Let's find the y-intercept. How do you guys find y-intercept? If they're asking a particular variable intercept, you always choose the opposite one and set it into 0. So I'm going to set x into 0 and compute y, right? On this thing. So there's 0 to the fifth, 2, 0 to the fourth, which is 0, 0, 0, right? So y-intercept is 0. So my graph is wrong. It shouldn't be crossing y here. Let's clean this mess. It's crossing y-axis where? Right at origin. Here we go. And I also see here immediately that one of the x-intercepts is 0 as well. Do you see that? Because if you have origin crossing, it crosses x-axis as well. So I will find x-intercept, one of them as 0, 2, which is in step 3. Again, step 3 says find zeros of the function, and there must be, but it's actually x-intercepts. So to find x-intercepts, I set the y into 0 and compute x's. And what's the strategy? Again, go up one back. If they're asking for x-intercepts or zeros, you first factor, set it into 0 and solve for. We have already set it into 0. All you need is factor this thing. This is only 2 terms factoring. Only 2 terms. How do you factor it? Come on, Maddie?
Take x to the fourth out.
Yeah, x to the fourth out. It's common in both, right? So when I charge x to the fourth to each group, this will drop to single x, this will drop to just -2. Now let's set this into 0 with multiplicity 4. I only set the bases into 0, okay? And this has multiplicity 1. I will set this into 0 and I will get x equals 2, right? Set this into 0. Multiplicity 1. And this is multiplicity 4. Okay? Alright. That's number 3, right? Let's see if there is anything else required. These are the x-intercepts, so let's sketch them. 0 and 2. I already have 0 here. So I told you one of them is already 0. The other one is, what was it? 2. 1, 2. Okay? All right. Step 4. I have already did this. I didn't wait until 4. I already did. Whenever I complete each step, I do it anyways. 5. Draw a sketch starting from left end behavior. Connect the x and y interest in order to appear from left to right using these rows. The curve, okay, this is important, will cross x-axis. Okay, there are two kind of x-intercepts. One is a touch point, the other one is cross point. Cross point, touch point. Okay, there are two intercepts here, right? This can be a cross point or touch point. There are two options, touch or cross. Let me tell you the difference between touch and cross. Touch means wherever your graph is, it's going to come towards it. Touch means it's going to touch it and bounce back like a ball. This is a wall. Your ball hits the wall and comes back. That's touch. What is crossing then? Crossing is like a bullet. Your graph comes here. It doesn't bounce back. It goes through it. Okay, this is crossing. So you can have the same thing. You can have a bouncing here. This is touching. Or you can have a crossing here. Now, how do I know which one is each intercept? Touch or cross? There is a test for it. Here is the test. We know that x-intercept is a cross point, not touch, if it has odd multiplicity. So I need to mark the multiplicity here. What was the multiplicity of 0? It was 4. It's even. So it's even. It's not odd. Then this is a touch point. Even means touch. So I'm going to call this one. I'm going to make a touch and bounce back whichever direction I'm coming forward to this. Okay. How about this one? This is multiplicity 1. It's odd, so it's a cross. Make a touch here, make a crossing there. Okay? So let's complete our picture according to this observation. I'm going to move this a little bit closer. And I'm going to move forward from here. And it says just touch and bounce back. I'm touching and bouncing back. Don't cross it. Don't go through it to the other side. And I need to go back to here, so you can't go indefinitely like this. You need to go back to this point, right? So if your ball bounced back, and if you need to visit this point again, you need to come up again. Go up. And this time, are you bouncing down again? No, it says cross. I'm going to cross it. And then I need to meet this end, right? You don't have to match it, just you can delete that one. Alright, looks better. Okay, any questions? So basically you start from the ends. To guess the middle part, you find intercepts and decide it's a touch or cross and connect it. Alright, there are extra steps you can make here. This is for extra testing, because I roughly estimated how deep this hole is. There is a cavity here, right? But how do I know it's this short? Maybe it's going further than I meant. So you need to test, take some sample values here between 0 and 2, for example 1, and see how low this goes. Okay? So you need to take, for example, 1 and substitute here. 1 to the 5th is 1. 1 to the fourth is 1, but 2 times of it is negative 2. 1 minus 2 is negative 1. Oh, so I see this is only going to negative 1, so my first guess was correct. This is a good value. So it's just to make your picture perfect, you just test some values, alright? So I'm going to delete my second estimate. And if you want to see how sharp this is and how do I know it's going a little bit slow, maybe it's a lot sharper here, right? This way. You can just take a 0.345 and measure it, how sharp it's going. But these are extra details I'm not going to check, alright? So you can just do these extra step 6. And also you can also test for symmetries. You can plot more points and test symmetries, but I call these optional. We don't have time to do all this long work. These are optional. Once you have a rough sketch, you're good. First 5 is sufficient, alright? Alright. Let's see if we can finish this part here. We found, oh, this is the previous question. Now this is X question. You can do on your own. This is another X question for you. It was number 6 right here. Alright, this end behavior is on the left down, on the right up, as many y-intercepts. By the way, functions cannot have more than one y-intercept. This is a ridiculous part. But it can have none. Sometimes it never touches. And y-intercept we found was 0, 0. How many x-intercept we found? 2. And the picture we found is none of these yet, because there are more on the top. Still, it doesn't look like any of mine, right? Oh, it does. It's this one. They just made it more flat on this area. So it's much more flatter on this area. Now how could I catch that? Because I didn't test some values. But this is again rough estimate, as I said. It's close enough. It's close enough. This is the best option. And you see on the end we meet, so it's E. Okay, this is the end of section 3.2. Any questions? Now we know what a polynomial is. We know zeros of polynomials or x-intercepts. We know their graphs. We know how to factor them, kinda, right? So that was it. But now we are going to find out more about them by going to section 3.3. If you don't have any questions. In this section, we will learn two methods of polynomial division. We will divide one polynomial by another one, and this will be helpful in finding zeros of polynomials. Again, why are we curious about finding zeros of polynomials? Why are they so important? Because zeros of polynomials are x-intercepts. We use them in graphing. And also zeros of polynomials are actual solutions of equations. So we want to find out, most of the time in real life we end up with equations set into 0, and finding their zeros is substantial, okay? And division of polynomials will be helpful identifying zeros of polynomials. Alright, now our first method of dividing two polynomials is called long division. Okay, so it's called long division. The other one is called syntactic division. Syntactic division, but which one would you prefer? I want you to definitely know long division. Long division is required. Syntactic division is optional. You may forget about it after the semester, but don't forget long division, because synthetic division is fast, very fast, but it's only applicable to only some divisions. You need to have the second polynomial dividing the first one, the long one. This is the big polynomial, so this is small one. The second polynomial must be only x plus a number or minus a number. That's it. If this is a square, you cannot use synthetic division. No. Okay? So synthetic division can be only applicable for special divisions. If you're lucky enough to have only x and a number afterwards, like x minus 4 or x plus 1, these are all synthetic. But how about this question? Can I do synthetic for this question? No, because it says a square. That's why I especially want you to know long division, because long division solves every question. It's long though. It takes a while. Tedious work, but it takes care of all questions, okay? So how do we do this? Here is the recipe. I put it on the right. And we will follow this recipe, but first, what is the setup? We need to set our division symbols up. So here is the division symbol, long division symbol. I put this notation here. Okay. The divisor, the small polynomial, goes to the left. This is called divisor. What is this one called? You know the special name for it? Dividend. It goes to the right here. Goes here, okay? Any questions so far? This is just the setup. We haven't started dividing yet. The solution, the result, is gonna pop up here. This is gonna be the result. And at the end of this division, not every two polynomial perfectly divide each other. Like, can you divide 11 and 3 perfectly? 3 times 3 is 9. Take away 9. There is always sometimes leftover items, right? Leftover number. This is called remainder. You expect to get a remainder on the very end. Okay? So there are 4 concepts here. Dividend, divisor, result. We call this actually quotient. We don't call it the result. Quotient. And remainder. You're expected to get 4 things out of this thing. The first 2 is already given to you. You basically find the last 2, quotient and remainder. Okay? Alright, shall we start? What is step 1? You are going to mark the leading term and divide it by the leading term of the divisor. Again, let me fix it. Find the leading term of the dividend and find the leading term of the divisor and divide them. So what is the leading term of the dividend? What is it? Leading term is usually the very first term, right? So is this the leading term? Is this the leading term? No, because it doesn't have the biggest power. The leading term is the biggest power. So when you are setting this up, don't just put the polynomial in the given order, please rearrange terms if necessary, and in this case it's necessary. I should put the first term as 4x to the 4th because it's the biggest power, it's the leading term. Then the next is this, and the last one is this. Now this is better. Now this guy is the leading term. Okay? What is the leading term of the divisor? 2x. So step 1, I divide those. Like this, 2x and 4x to the 4th. No. Top should be the leading term of the dividend. 4x to the 4th first, 2x next. And what is the result when you divide this? Basically, you need to cancel out and reduce. 2 goes into 4 twice, right? And when you cancel 1x from this guy, you end up with 3 of them. So we have 2x cubed. Okay? Now what do I do with this 2x cubed? So we're done with this step. We're going for second step. You take this 2x cubed, take it here, and multiply the divisor, entire divisor with it. Multiply the divisor. But before that, sorry, number 1 is not over. You found a result here, right? Put it into quotient box, 2x cubed. Don't forget that, because I keep forgetting it all the time. 2x cubed, the result we got, first result, you put it into the box here. Then we multiply that 2x cubed with the divisor in step 2, which will give us 4x to the 4th minus 8, right? Is it 8? No. Usually during the exam rush, you guys forget to multiply the second one. So I wanted to point out that 2 times negative 8 is negative 16x cubed. We multiplied the divisor. And is this a coincidence that 4x to the 4th happened to be the same as with this leading term? No. They must always match after the second term. They are matching. And what do I do with this result? We subtract the result from the dividend. You put this under the dividend and subtract. Alright. I didn't prep this question well enough. I see my mistakes now. It's not a mistake. It just makes our life harder if you don't do those prep steps. What did I forget? Look, x to the 4 and x to the 4 are right behind it, right? What is right under x squared? X cubed. Looks like they are matched up, but are they really matched, x squared and x cubed? What prep step did I miss? If there are some skipping power, 4 to 2, there is a skipping power, right? Make sure you show them here by putting, if that term is missing, how can I put it back here? Put it as, Zero. 0x cubed. Look, there is no x cubed, that means 0. And now you have 58x squared. And then is it minus 96? Now after x squared there is another skipping power, which is first power, right? So it is 0x and 96. This is better. Okay? And I don't have to write these, but it's 0x squared, 0x and 0. This is this is time consuming. I'm not gonna write these. If this second, you don't have to do the skipping powers and the second row here. It just makes sense. 0, 0, 0. Okay. Now, what do we do next? We subtract this. That means 4x to the 4, take away 4x to the 4. What is the result? They do cancel. And nothing comes down. It's 0. Now, I'm going to subtract 0x cubed and minus 16x cubed. 0 take away minus 16 is minus 16x cubed. Right? I combine these two. Right? Everybody agree? 0 and negative 16 makes negative 16. Come on, right? Can I go ahead? Something fishy? Something you don't like? Everything okay? I need confirmation. What is wrong? Yeah, look, this is the situation. You have 0 here, 0, and then we are subtracting minus a minus 16. That's the situation. Subtracting a minus 16x cubed. So these two make positive. 0 plus 16 is positive 16. So to avoid any confusion, possible mistakes, this is what I do. When I start, before I start the second session, once I put this, I take a different color and do this. Flip each and every sign here. This is plus, flips to minus. This is minus, flips to plus. And then all you need to do is addition. Instead of subtraction, by flipping the signs, I already did the turned the subtraction into addition. Now it's addition. 0 and plus 16 makes plus 16x cubed. Okay? I don't flip any signs on the first row though. The others just transfers down. Look, we bring down the next term from the dividend and repeat this process. So just 58x squared plus 0x minus 96. They have nothing underneath them, so they just transfers down here. Is flipping the signs okay? You don't have to do this. This is my way. But keep in mind you're subtracting. So this sign is going to flip when you're doing that. 0 plus 16 it turns into. Next, are we done? We have completed the entire procedure and I have something remained here, right? But does this mean it's the end of procedure? Can we go and finish our homework assignment? No. When do we know we need to stop? It's because it says repeat the process. You're going to rinse and repeat this process over and over, sometimes 10 times. How do I know it's over? How do I know this is really the remainder? I cannot divide it anymore. Is there a test that can tell us when to stop? How do you know when to stop? Anyone? Because I know I have a feeling I need to do this again. I will pick the leading term of these guys, divide, multiply, put something more, subtract, keep going. But when do I stop? Okay, anyone knows? Now, this is what you need to test. Check out the power of the leading term of the divisor, which is 1. Power of the remainder, 3. You keep going until this remainder power is definitely less than this power. So that means I need to stay less than 1, which is 0. That means I will keep going until I get x to the 0. In other words, x's disappear. I will keep going until x's disappear. What if this was a square? It was a 2. If this was a 2, I would keep going until this drops to power 1. Do you understand? If this is 2, I will keep going until this drops to power 1. Always 1 less than the leading power degree of the divisor. Okay, we're doing this one more time then. This part is over. 1. Take the leading term of the dividend, take the leading term of the divisor, divide them 8x squared. Take 8x squared into here. But what do I put between these two terms? Plus or minus? Plus, because positive 8 is the answer I got here. It goes with the sign you got. It's both positive, so it's positive. Next, I take that 8x squared and multiply with divisor again. And this will give us 16x cubed. It should match to this. It's matching. Minus 64x squared. Perfect. And I subtract 16x cubed minus 64x squared. How? Flip the signs. These are cancelling when you flip the sign. Positive 64 take away negative 58 is 8. And these transfer down to 0x and minus 96. And I keep one more round because this power, actually 2 more. This power is not less than that. Yes.
It's 6x squared.
Oh, thank you. I'm glad we fixed that on time. If we go with the wrong answer, we keep repeating the same mistake to the next steps. It's hard to fix. So slow down and check back often for your mistakes, like we did. Okay, like we caught one. Okay. So what is the new leading term? 6x squared. I divide it by the leading term of the function, which is 3x, and I put 3x to the power, to the quotient here, and multiply 3x by the divisor, which gives us 6x squared minus 24x. 6x squared minus 24x down here. I flip the sign, cancel these, and I get 0 plus 24, 24x minus 96. Is this the end of the process? No. Now they have equal powers. I need to go one more round, and this is the final round. I will do it here. 1. Mark the leading power and divide by the given divisor power, leading term, which is 12 only. Right? Second, take 12 and multiply with the divisor and get 24x minus 72, no, 96. And take this away from this guy. Sorry, these are... When I flip the signs, however, oh my god, it has 0 remainder, nothing left. They all cancelled. So my result is this. So this is how I write this answer. I go back into this question and say the result of this division is this quotient, 2x cubed plus 8x squared plus 3x, and I have no remainder, so I don't have to put here. If there is some remainder, I would put, for example, if you had some remainder left 5, I would put it in the numerator, and the denominator would be here. If there is some remainder, you put it here. and you still need to it's pending division by 2x minus 8. You put it underneath, but we are safe here. You don't have to do, because remainder is 0, 0 over anything is done. I have a mistake. I forgot to carry something. What is it, Chris? 12. Yeah, in the last step I was rushing. Once you get the result here, don't forget to put to the quotient. Now this is the complete answer. Alright, check this on. Please somebody read me the answer, because I don't want to flip. If I flip, I lose.
8x squared.
Q is 8x squared plus 3x plus
3x.
Yeah.
Alright. Okay. So we will continue this tomorrow with synthetic division, and then we will apply this into finding zeros of functions. Not tomorrow, Friday.